All right, we've got our plates and pegs, and we're going to need some brackets. So I'd like to introduce the thin feature, although ultimately I'm not going to build these with the thin feature. It could. Um, Going back to that configuration strategy, we're going to build a couple of these in the C bracket, the Z bracket, um, or actually it looks like the three items. This again can lend itself to configurations. I just have to plan far enough ahead. So, like I said, I do want to do a thin feature. If I'm just making one real quick L bracket, then I don't have to take it too far. So I'll make sure that that one got saved. We're not using that one, so go ahead and save that one as well. And this will be a new metric part. And on the front plane, I can generate a sketch and need to double check my sizes, 40 by 40. And got a little carried away with that one, so 40. So this will be an interesting, since I clicked and I'm playing with the sketch numeric input at the same time, this will be an interesting. So with the click, I actually got the double click to terminate it to work. So and even though I saw the perpendicular, it didn't stay perpendicular. So worst case, I'm going to bring that one out horizontal, bring that one up vertical. And because I saw the white, but it did not put anything over here in the existing relations, I'm going to apply horizontal, or I'm going to come back over here to the property manager and apply vertical. All right. So at this point, let's see, our width is 30. So as long as I have this open geometry, this is going to generate, when I go into the feature, a thin feature. And thin feature is going to be checked. You are not going to be able to uncheck it. 10 millimeters on the thickness is fine, and I want it to go that way or that way. It's an interior based on the dimensions that I've given it. And if I stay with the midplane, then I'm going to tell it that that is 30. So the advantage of the midplane here, for the peg, it could have gone either way or any of the ways. This one's going to give me the advantage of keeping the holes related to that center line, to that origin. All right, and for this one, we're going to go with the sketch geometry. We'll open up for a piece. I ignored the numeric input right after I did that, so 10 millimeter. This is going to be 15 millimeters off of that. Nope, it gives it as 25. The rest of them, nope, I guess it does give them at 25. So we'll go with the 25. And because these are going to stay centered, I'm going to select the origin, Control select the center point, and make it vertical. And then this is going to be an extrude cut up to next. It might be a through all, but I don't think we're going to run into anything on this one. So notice that my boss extrude is called extrude thin. It's reminding me of why I've got that geometry. So we open up a sketch and I type in the 10 and enter, and it applies my dimension. And then we go to the smart dimension. And if you're okay with the numeric input, stay with it. If you're not comfortable with it, turn it back off. I don't have a preference either way. Just want you to be aware of it. So extrude and cut. And we'll go, if I tell it through all, and I was going to stay with this geometry, then we could go ahead and have that be a through all. So save, and this is going to be my L bracket. So maybe we'll go ahead and just treat these as that same process. We'll have individual components, and then we'll go back and have one that is bracketed, or just the bracket file. So it's bracket, and then I want to do a save as copy and open, because I do not need to redo all of these. Then this will be the Z bracket. Make sure that's what they're calling it. Yep, actual Z bracket. We're going to deal with the part numbers later, since I keep kind of catching my eye. Save as copy open. Go ahead and close the original. All right, so if I stay with this grouping, then I want to open the sketch, and that was 30, and that was 40, and I'm still okay with the thin feature, but we do have to check some numbers. So 30, and then the overall becomes 50 because we added that other 10 in. I'm okay with that. Let's see, the 30 should, because it offsets that way and that way, we should end up with the 40 without any problems. So let's go ahead and hit OK. All right, so 40. And we go back here, we measure 50. All right, so that one's okay. The only thing I have to do here, if I'd done the C bracket next, that one should have gone ahead and run into it, but since it didn't, we'll go ahead and notice I turned the sketch numeric input off. So now I have to put those values in. What did they use as a datum here? 15 off of the front, which is fine. We'll pull that number, go back into the select, grab the center point, grab the origin, make that horizontal, and extrude cut. And that might as well be an up to next. All right, and then we'll save that as the Z bracket. I'm going to go ahead and close that because the L bracket was kind of my beginning, or the one that I wanted to contend with. Save as, copy and open. We'll make that the C bracket and save. And we'll close. All right, so on the thin feature then, actually we'll just go ahead and edit the sketch, but my thin feature is going to put everything on the inside in this case, so that dimension becomes 50, and the line would come out here horizontal, and I'm looking for that inference. It did not apply it, but that's okay. We have a couple of choices. And again, as you are working through this, just keep in mind that if I go in points, I'm going to get vertical. If I go lines, I'm going to get equal. They both do the same thing. As far as the alignment, there may be some downstream, but either way, they get the geometry. So the first cut extrude was up to next. The second cut extrude was through all. This one could have been through all either way. It really wouldn't have mattered. If this one was up to next, it would have terminated here, and I would have had to go back and edit the feature just to run through. If I were to tell it up to next, or up to surface, or up to vertex, it would not terminate at the very last one. So that being the case, I kind of foresaw that that was what I wanted to do, so I made it a through all. All right, so that gives me 3 separate brackets. How do I make this a configuration? Well, I don't know that I would use the thin feature. The thin feature would be okay, it just would not be my first preference. So if we go into the part metric and the front plane again and open the sketch, let's see what we can do with some offsets. So instead of the thin feature, I am going to go with the and I'm going to have to double check the Z bracket, because looking at this, the 30 by 40 by M40, 30 came off that way. I think I did that all right. Well, we'll go back and double check. Anyway, where was the L bracket? No, it came 40 by 40 and we started with that, so that'll be all right. But if you happen to think of something, if it comes into play, that's the time to resolve it. We don't want to find out later that, hey, I did think of that, I just didn't do anything about it, so now I've got to deal with it after the fact. So add dimensions, 10 millimeters, should be on the selected chain, and the construction geometry, nope, it's not letting me cap the ends, so that's interesting. Well, let's see if, oh, there we go. And so I did have to pick one of them, and because select chain was on it grabbed both of them. And then if I cap the ends, well, those are pretty, but I just want to go with lines. All right, so that gives me that one. Let's go ahead and build this out, because I'm thinking in terms downstream of the configuration, but I'm also wanting to make this way more complicated than it needs to be. So if I did the Z bracket, I would have a box going this way, and if I do the C bracket, I'll have a box going this way. The question is, do I want to build those into this sketch and share the sketch, or yeah, not sure. I think we'll do those separate. It'll make more sense doing it separate, but I'm just keeping in mind that I could do all of my geometry out of this one sketch and share it across all three parts in that same group. So decision time, I'm taking the left branch, whatever that is. All right, so 30 millimeters. I'm going to do the same types of things. Do I want to introduce the whole wizard? There are some advantages to the whole wizard here. So I'm gonna go ahead and say stay with the extrude cut, but keep in mind that you have the whole wizard, and whole wizard is this icon up here. It's going to let me change this to a tap tool or to a counterbore or countersink if I want to. Now, some of these would lend themselves to clearance holes for screws, because those pegs are nice for alignment, but they have no mechanical fitment. There's no compression, there's no nut, bolt, screw, anything tied to that is going to keep it together. Are we going to glue them together? This becomes part of our scope of work that we have to be thinking about, and even if it's that 10 seconds of um, uh, think about it, address it, and move on, it's still in the frame of reference of this is what I decided and why I decided it. So 10 millimeters up to next is fine. Now this one's going to be on the bottom, so maybe I'll go ahead and do through all, because it would, well, no, actually it wouldn't. All right, so we may have to think about generating some of that geometry. So I've just kind of naturally slipped into that parent-child of unlike the save as and modifying the thin feature. When I build that next piece of geometry, it's going to be after the whole wizard, so it's really not going to cut through all anything. So 40 by 40, we have the 25 off the bottom, still centered, and this time I'm not getting the perimeter of the circle, so that doesn't play in. I have to go to the point. Quick mention on the hole wizard: wherever you place a point, you will get a hole. So you pretty much only want to put points where you need them, and that is one of the reasons why we want to pay attention to the like a circular pattern or anything that will involve those, because occasionally it will generate an extra point, which skews the instance count later on. All right, so all of that should be good up to next through all. We go into positions and make sure that I'm mentioning everything with the hole wizard. The type is a simple hole. We've told it that we're metric. We're going to drill sizes. You can use dowel sizes, but when it gets over to the drawing, it puts a dowel symbol, which is usually a tighter tolerance item. And I doubt that our pegs are, since they're not being called out as pins, they're being called out as pegs. I don't know that they're going to be as tight a tolerance. So the 10 millimeters through all, no countersinks. Tend to, if I want to countersink, I do that as a generic call out on the drawing, unless there is a reason to put it in otherwise. So select control, select the origin and the point. Those are vertical. We'll go grab our smart dimension. All right, so the two ways I'm doing the smart dimension is off of the command manager or the right click and picking the smart dimension. We go ahead and accept. All right, when I save this, this is going to be the bracket. And now I can start thinking in terms of how I'm going to set this up for configuration. So first one is to just add this configuration, and this is going to be the L bracket. And I think for the configurations, I was giving everything in all caps, and that's going to pull the configuration name, and I'll hit save one more time. All right, so my decision, let's do the C bracket first here so that I can kind of finish my thought on what's going on with this geometry. And we're going to add this now separately. So on the front plane, I'm going to open up a sketch and we'll find coincident to that corner. I have a thickness, but I don't know that I can make those equal between the features. Oh, well, if I can, I'm going to. So selecting the feature, selecting the edge, telling it that it is equal, and then also collinear. Even though this edge exists forward of the front plane, because we did mid-plane, I'm projecting back into that plane and saying I can do this sketch without any dimensions in it. And when we do our extrude, let's see, mid-plane to a distance. Well, if I make a change, I would really like to see that it's not giving me up to next. It's not going to be able to calculate that. So let's do up to vertex on this one as the example. So vertex would be a corner. And we are definitely merging the result. In direction 2, I could do vertex again, but surface is a bigger target usually, and I can generate that geometry. So here is that point where, and I did not create my my configuration. So this is where we do the test and how we modify the geometry. All right, so at this point, I would want to reorder these. If I set up a condition where these little lines, all right, so my parent child, all right, that is parent, I cannot put boss extrude 2 before boss extrude 1. But when I look at these, they're not tied to anything below. So there are no child features, meaning that this did not have any, any real implications for its geometry. So I'm still in the L bracket. I did not jump back to the default. So here's where I get into my suppression. All right, I suppress that feature out. Oh, let's go back into the default. And in the default, that wasn't unsuppressed. So notice that now, because of the through all and the hole wizard, it's going to terminate at the back of the C bracket. All right, so then I need to make another one, add configuration for the C bracket, and I'm staying with all caps. And we're going to switch to configuration name. And while I'm here, we'll add the configuration for the Z bracket. And configuration name, and OK. All right, we go back to the default. And on the default, I'm probably going to go ahead and just suppress that one. The L bracket is correct. The C bracket is now correct. The Z bracket, we go back and we're going to extrude, or we're going to suppress that extrude one more time. And into the front plane, back into our geometry. And we're going to see, and I do like to kind of rotate that over. So if I go there to there, that can be equal. And then if I pick these correctly from there to there, that should be equal. And then the extrude boss base. And what I'm trying to build in here is a little bit of making this very stable. If something changes, let's go up to surface on both of those, direction 1, direction 2. Make this very stable to where if I start changing dimensions, that it will stay in kind, that everything will move like it's supposed to. So if we go that way, we have 40. If I go that way, I have the 50. And the last one that we need is to jump back into, since we're using the whole wizard on this one, into the hole, 10 millimeters through all, go into the positions, place my geometry. They went 15 off of that side. Oops, I switched to lasso selection, so that'll be interesting next time I do a window pick. And we go ahead and select. So this was all done pretty much. C bracket, default goes back. You know, and sometimes with the defaults, I'll do something like, let's just suppress everything but the base geometry. So it's very apparent that I have the L bracket and then the Z bracket, and there we go. All right, so we'll save that, and now we're ready. I think we have all of our parts are ready to start talking about assemblies. All right, let me jump back in one more time before I conclude the video. Just keep in mind, again, that if you did this the first way and built the 3 and want to use those, that's fine. If you are comfortable with the configurations and want to use the configured parts, that's fine too, but they are separate entities, and we'll use them similarly but a little bit different, but there are advantages to the configuration.